Now, let me show you one example. And let's look at the page 517, problem 86. Now, we need to show this equation is not an identity. So we have equation cosine of 2x equal to 2 times cosine x and times sine x. So this is an equation. And the problem says this equation is not an identity. Okay, so how to prove this equation is not identity? And first, we know that both sides are well defined for all real numbers, right? X can take any real number, and both sides are well defined for them. So now, when we just try to find some real number, and this number does not satisfy this equation, then we are done. Then we know this equation is not identity, because if this equation is identity, then all the real number must satisfy this equation. But right now, we can find some number which does not satisfy this equation. Then we know this equation is not identity. So first, you may try some special angles. For example, 0, half pi, pi, 2 pi, or the pi over 4, pi over 3, or pi over 6. Okay. So right now, let's just take the x to be 0. And then we know the left side cosine of the 2 times 0, this is equal to cosine 0, and this is equal to 1, right? And the right side, you have the 2 times cosine of 0 and times sine of 0. And we know sine of 0 is equal to 0. So 0 times anything is equal to 0. So this guy is equal to 0. So that means 0, this number does not satisfy this equation, right? So we have the cosine of 2 times 0 not equal to 2 times cosine 0 times sine 0. And this just implies this equation, okay, is not an identity. Okay. Now let's go to the page 517 and let's look at the problem 90. We need to use identities to simplify this expression. And let me copy this expression on the whiteboard. So page 517, problem 90. We have cosine of w times sine square of w and plus cosine cubed of w divided by secant of w. So this guy, and tell me what should I do in the first step? Fact the numerator, right? Fact out this cosine, because in the numerator, these two terms have the common factor cosine w. So let's first try to fact out this cosine w. So we have the cosine w, and then inside parenthesis we have the sine square w and plus, okay, so originally you have the cosine cube. So right now you fact out the 1 cosine w, then you have the cosine square w remain, right? Now this guy, generally we try to replace any other 4 trigonometric functions, okay, by sine or the cosine, because we are familiar with the sine and cosine. So right now, let's use the reciprocal identity to replace this secant w by 1 over the cosine w. Okay. Now, inside parentheses, we can use the fundamental identity. Okay, we know this is equal to 1. So right now we get the cosine w over the 1 over cosine w. And then if you flip this to the top, then you get the cosine square w. Okay. Now let's look at the 96. One minus secant square w over tangent square w. And I just see we like to replace other 4 trigonometric functions with the sine or the cosine, right? So right now, let's deal with this part because this is more complicated. So we can use the reciprocal identity to get 1 over cosine square w to replace this secant square w. And then we can use identity from the definitions and rewrite this tangent square w as sine square w over this cosine square w. Now, to simplify this complex fraction, we multiply both the numerator and denominator by cosine square w. Then this guy and this guy cancel, and this guy and this guy cancel. Then you get 1 minus 1 over sine square w. Right? Okay. And then, now tell me what is the next step. What should I do right now? Yeah? Try to rewrite this using one reciprocal identity. And we know 1 over sine w equal to what? Cosecant, right? So now this guy is just equal to 1 minus the cosecant square w. And what is the 1 minus the cosecant w? Cosecant square w? Remember one of the Pythagorean identities, right? So this guy is equal to, let me write out that, okay, Pythagorean identity, we know 1 plus the cotangent square w equal to cosecant square w, right? So now you move this to the left side, you move this cotangent square to the right side, then you get the 1 minus cosecant square w equal to negative cotangent square w. So finally, get the negative cotangent square w. And then done.